Hi everyone, welcome back to our channel. I'm Shakur and we are here to solve another problem from chapter 1 of Beer Johnston Mechanics of Material textbooks together. I hope you find it useful. Let's take a look at the question together. Two solid cylindrical rods AB and BC are welded together at B and loaded as shown. These and these. Knowing that P equal 10 kips, find the average normal stress at midsection of A rod AB, B rod BC. Let's go back and start with the basic formula we had. I want to emphasize again that this is the most important formula in mechanics of material. If you remember, stress is equal to load divided by area under consideration. The problem statement provides the load, one load of 10 kips and another of 12 kips are applied to member AB, PAB, AB. Therefore, we can say that total load is equal to 10 plus 12, which result in 22 kips. 22 kips. The area for member AB is easy to obtain since we already know the diameter. I will use the formula we converted in previous session. The area AB equals P divided by 4 multiplied by the square of the diameter of member AB, which is d sub 1, P, which is approximately 3.14, divided by 4 multiplied by the diameter, which is 1.25 inch squared. Be careful, make sure you use the inch and do not substitute in number incorrectly, and do not forget to square the diameter. Using those values, the area is approximately 1.2272 square inches. Now all we need to do is divide these two values, this and this, according to the formula we mentioned at the beginning. We write that stress AB equal to load applied to member AB divided by the cross-section area of AB, AAB. That means that the total load of 22 kips divided by an area of approximately 1.2272 square inch, which give us 7.94 kips divided by square inch. That's complete part A. Part A. Let's move on part B. Okay. For part B, about member BC, the applied load is given as 10 kips according to the what's stated in the problem. I have one question for you that I want you to answer in the comments. Why did we account for both force on member AB, but for member BC we only consider the 10 kips force? Okay, the next step is to calculate the cross-section area. First write that P BC equals 10 kips. ABC, which is exactly the same as in the previous part, except that our diameter is 0.75 inch. Okay, thus we write that the area of member BC equals P over 4 times D2 squared. In other words, P divided by 4 multiplied 0.75 squared, and the cross-section area of BC comes out to approximately 0.44 square inch. We divide the load by this area, and finally stress for rod BC is approximately 0.44 22.64 kips per square inch. I hope you have learned this problem as well.